Let's solve the problem. Count the coprimes. Let's read the question once. You are given an array of positive integers. Your task is to count the number of pairs ij such that ij should be between 0 and n minus 1, and notice this, I should be less than j, and GCD of array of I, array of j should be equal to 1. Okay, so let's see the example. In this, the given array contains elements 1, 2, 3, and the output is 3. And explanation, you can see 0, 1, these two numbers are coprime, that is the GCD is equal to 1. GCD of 1, 2 is 1, GCD of 0, 2, 0, 2, 0 and 2, that is 1 and 3 is again 1. Similarly 1, 2, GCD of 2 and 3 is again 1, hence the answer is 3. Similarly you can see this. Okay, so how to solve this problem? Let's see the constraints. Constraints are given the size of the array as 10 to the power 4, and the elements inside the array will be in the range 1 to 10 to the power 4. Okay, so how to solve this problem? Let's erase this for now. Okay, how to solve this problem? Let's see. So firstly, how to come to an approach to solve this problem. You can see the size of array is 10 to the power 4. That is, if you are thinking of code like which runs in n square, this won't pass because this is approximately 10 to the power 8 iterations and won't pass. Okay, so n square will not pass. For this question, the extreme naive approach would simply be run two loops, and then inside those two loops calculate array of ij. If it is equal to 1, increase the counter, else don't increase it. If I show the code, this will look something like, we will have two loops, one going from I is equal to 0 to I less than n, I plus plus. Let's code it. Okay, answer is equal to 0. If I will do this, j is equal to I plus 1, j less than and j plus plus, and answer we have already initialized. Let's initialize the size as array dot size. Okay, so what we will do here is, we will simply, what we will do, answer plus is equal to, if this is the inbuilt function in C++, if array of ij is equal to 1, do answer plus plus, else don't do this, return answer. In this case, if we try to run this code, okay, firstly let's run this code, let's submit it. It will give TLE because here the time complexity is, we are running two loops, that is n square, and then this GCD function takes log n time. Okay, so the time complexity will be equal to log, or you can say order of n square, and log of not n, basically it is maximum element in array. Okay, so the time complexity is this, and this will not pass. So how to solve this problem? Okay, so something like n log n will definitely pass, something like n root n will also pass. Okay, these are the complexity which will pass. Okay, so how we will solve this problem? So whenever you see something like GCD of array of I, array of j, or GCD of any two numbers, if it is equal to 1, what it simply means, let's decode it. If GCD of AB is something like x, what does it mean? It means x divides x divides A, and x divides B. This simply means this. And you can see the constraints. The array of I runs up to 10 to the power 4. Okay, so what we will do is we will iterate through every x. Okay, we will iterate through every x, and what we will count is we will basically count dp of x, which gives number of pairs whose GCD is equal to x. We will do this. Basically, we know what we know is GCD of AB, if it is x, it simply means that x divides A and x divides B. So what we can do is we can iterate through x, every x, and begin to find the number of pairs in the array whose GCD is equal to x. Did you got me? Now you will say, how did you come to an intuition to solve this problem like this? So basically, I basically came to solve this problem using this method because of this fact, that is, if GCD of AB is equal to x, x divides A and x divides B. So simply, why can't I think of something like, if I iterate x from 1 to the maximum element, because GCD, the value of x can be up to the maximum element only. If I do this, and if I somehow able to do this, that is calculate dp of x, then what will be my answer? It will simply be dp of 1, because what dp of 1 will give? Dp of 1 will simply give number of pairs in this array whose GCD is exactly equal to 1. Okay, so how we will now let me write this. So basically, how we will calculate dp of x? How we will calculate dp of x? Okay, so for this, what we can do is, now suppose let's take an example. Okay, if I have the array something like 2, 4, 6, 12, 7. Suppose this is my array. In this case, and also suppose we have 3. In this case, what will be our answer? Our answer will simply be 2, 3. 2, 3 makes one pair. 2, 3 makes one pair, and then 2 and 7 makes another pair. Then 7, 3 makes one pair, and then 3 makes pair with 4, 3 makes pair with 6, 3 makes pair with 3 don't make pair with 6, sorry. 3, 4, 3, 6 not, then again 7, 12, 7, 4, 7, 6, and 7, 12 also. That is 1, 2, 3, 4, 5, 6, 7. I have 7 pairs. This is the answer. That is equal to 7. So how we will solve it? Okay, so okay, let me comment this out. Before solving this problem, let's solve a question where you are given an integer. By this problem, you will surely be able to, if you are able to tackle this problem, you will surely be able to tackle this problem also. Okay, so what is the question? You are given an integer n. Okay, and what you have to do is you have to count, you have to return an array, and here n is less than equal to 1 is 6. You have to return an array where array of I will be equal to count of numbers whose GCD is equal to I. Okay, you will have to do this. Count the number of pairs. Count the number of count of pair. Count the count the count the count the number of pairs. Count the number of pairs whose GCD is equal to I. Okay, we are given an integer n, and count the number of pairs. From where will you get the pair? This pair will be of the format xy, where both xy, x and y belongs to n. Or you can write something like x and y, where x and y this. Okay, basically array of I will give count of number of pairs xy, number of pairs xy, where x or y is between 1 and n. Okay, you will have to do this. So how will you solve this problem? For solving this problem, let's consider we have n is equal to 50. Okay, now what dp of 2 will do? It will return all pairs with GCD equal to 2. This will do this. Okay, so can you tell how many numbers are in the range 1 to 50 who are divisible by 2? So there are approximately n by 2 or 50 by 2 numbers which are divisible by 2 in the range 1 to 50. 50 by 2, that means there are 25 numbers in the range 1 to 50 which are divisible by 2. The numbers are 2, 4, 6, dot 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 dot. Okay, dot dot 50. There are 25 numbers. So if I consider all these numbers, and if I consider all these numbers, then there are how many numbers? There are 25 numbers, and if I pair all of them, this will simply be 25 C2. 25 C2. Okay, this will simply be 25 C2. That is, we can pick any two numbers, and let's suppose we consider their GCD to be 2. But now you will tell that there are numbers like 6 and 12 whose GCD is not 2 but it is equal to 6. Okay, we are coming on to it. So what we will do is, we will do dp of 2 is equal to what we will do. We will do n is 50, and divided by 2 into n divided by 2, n divided by 2, n divided by 2 minus 1 this. That is basically what I am doing here is I am doing NC2. NC2 is equal to n into n minus 1 by 2. So here NC2, here n, basically here not n, let's suppose I call it m, MC2, and here m is equal to n by 2. For dp we are calculating dp of 2. Okay, so m is equal to n by 2, and n by 2 is equal to 25. Okay, so basically what I'm doing is I'm calculating 25c2. 25c2 simply will be equal to m into m minus 1 by 2. That is I'm doing here. Okay, m into m minus 1 by 2. I'm considering all these numbers and I'm picking any two numbers from this list. And then what I will do is I will run another loop 2 into I, and I less than equal to 50, and I plus equal to 2. And what I will do is I will subtract dp of 2 minus equal to dp of I. Okay, that is what I am doing. I am considering all these numbers, and I'm picking any two of these. This is given by m into m minus 1 by 2, and then I am subtracting from it dp of I. Okay, basically what I am doing is for calculating dp of I am considering all these numbers, and then I am subtracting all the multiples of 2. That is, here you can see 2 into 2. Firstly, firstly it will run from, since I am considering dp of 2, so it will run from 2 into 2, 4. I will subtract dp of 4, dp of 5, dp of 6, dp of 7 until dp of 50. Okay, this will, after running this loop, I will get dp of 2, which will simply be equal to the count of number of numbers whose GCD is exactly 2. Okay, did you get this? How I solved this question? That is, you are given an integer n less than equal to 6. Basically, if I have to write the code of this, how will it look like? It will simply be, okay, so basically what I am in this question, I forgot to tell you one thing. That is, for calculating dp of 2, what I am doing, for dp of I, what I am doing is I divided by n divided by I into n divided by, or simply I can run, okay, let's do this, n divided by I into n divided by I minus 1 by 2. I am doing this. Okay, this, and then I am subtracting dp of 2 into I plus dp of dp of 2 into I, dp of 3 into I plus dp of 4 into I. I am doing this. That is for dp of 2. For dp of 2, what I am doing, I am subtracting dp of 4, dp of 6, dp of 8. For dp of 3, what I will do is I will subtract dp of 6, dp of 9, dp of 12, so on and on and on. Okay, so you can see for dp for calculating dp I state, we are requiring the greater ones. That is, for dp of I, we are requiring dp of 2, dp of 2 into I, dp of 3 into I, basically, which gives us a hint that we need to run loop from n to 1. Okay, so if I write the code, it will look something like dp of n greater than equal to 1, and I minus minus, and dp of I will simply be equal to n divided by I into this one by 2, and then I will run another loop, j is equal to 2 into I, j less than equal to n, j plus equal to I, and I will subtract the p of j. Okay, this, and then you can store them in the vector and return the result. Okay, this is all that I explained you, and this is actually what matters to solve this question. So and if you got this question, uh, there will be very little modifications in this question, and you will be able to solve the question count the coprimes. Okay, for that, what we will do is, basically what I am doing here, I am for dp of I, what I am doing, I am aggregating. Basically here you can see it here, for dp of 2, what I am doing, if the limit is 50, I am collecting the list of all the numbers divisible by 2. So basically when I am running a loop from I is equal to, what I will here what I will do is, I will run a loop from 10 to the 4 until 1, or you can simply run a loop from the maximum element of the array until 1. And what you will do is, for each number, find all those numbers in the array which are multiple of I. Okay, and then if suppose you found that there are m elements, there are m elements in the array which are multiples of I, then what I will do is, I will simply initiate dp of I equal to, I can select any two numbers over these m elements, that will simply be equal to m into m minus 1 by 2, and then I will run a loop and simply subtract the GCD, subtract all the GCDs which are multiples of the current I. Okay, so how we will solve that? So basically, let me erase this, and now I will talk about, or let's comment out this. I may require to explain you things using this. Okay, so now how we will solve this question? You got what I intended to tell you from this question. So basically what we got from this question is, we need to find, for any number I, we need to find all its multiples, number of multiples present in the array. So for that, what we can do is, we can create a frequency vector. So if firstly extract the size n, and then create a vector frequency. I am considering a size of 10,001 because I know that array can be max up to 10 to the 4, or you can simply what you can do is, you can simply find the maximum element that is present in the array, and you can initialize the frequency array of size maxi plus 1. Okay, and then what I will do is, I will do frequency plus plus for every element that is present in the array. After that, I will create another array multiples, okay, of size exactly 10,001. What this will store is, it will store the number of numbers which are multiple, that is basically multiples of x will give number of numbers in array which are multiples of x. Okay, so for that, what we can do is, I is equal to 1, I less than equal to 10,000, and I plus plus. What I can do for calculating multiples, I can simply do, I can start j from I, j less than equal to 10,000 and j plus equal to I. And what I can do here is, I can initialize a count is equal to 0, and I simply can do count plus is equal to frequency of j. Okay, and then I can store multiples of I is equal to count. Here you can see this is basically what we call sieve. Okay, you don't have to remember the name, or you can remember it, it is up till you. So this is basically what I am doing. For any number I am going through all its multiples. Okay, you can see here for 1 I am doing first j is equal to 1, then 2, then 3, 4, and I am counting the number of numbers that are present in the frequency map. Okay, and I am increasing the count, and I am storing multiples of I is equal to 1. This is pretty easy, you can understand this. Okay, so now after this we have created a multiples array where the multiple x denotes the number of numbers in array which are multiples of x. Okay, now let's create the dp vector, dp of, okay, where dp of x denotes number of numbers which are number of or we can say count of numbers whose GCD is equal to x. Okay, for this what we can do, I showed you that we need to run a loop from starting from n up till 1. Here n is equal to, where n is the maximum element, I greater than equal to 1 and I minus minus. Okay, so basically here how many multiples I am considering for a particular I value, I am extracting how many multiples are there in the, or how many numbers are there in the frequency map or the array, how many numbers are there in the array which are multiples of I, and then there will be approximately, there will be not approximately, there will be exactly multiple into multiple minus 1 by 2. This will be the count of numbers, that is basically for I am calculating number of multiples of I that are present in the array, and I am pairing, I am selecting any two numbers from those count of multiples. Okay, this is basically multiple C2, that is the number of ways to select two numbers from the count of multiples. Okay, after this what I will do is I will run a loop, exactly this one, run a loop from 2 into I, j less than equal to 10,000, j plus is equal to I, and I will subtract dp of j, and I will store dp of I is equal to count, and then I will simply return dp of 1. Okay, this is the code. Let's run this code and see if it runs fine. Oh, okay, we need to comment out this. It is running fine. Let's submit the code. Okay, it runs fine. So this is all about the solution. I hope you liked the video. Thank you.